Hello students.
Today we are going to learn the basic structural geometry of a crystalline solid. Before going into detail of that, you should know what is the unit cell of crystalline solid. Unit cell of a crystalline solid is the smallest repeating structural unit. When unit cells of same crystalline substance are repeated in space in all the direction, a crystalline solid is formed. So this can be considered as a unit cell. This, all these are unit cells. Each point of intersection at the lines in the unit cells represent the constituent particles, be it an ion, be it an atom, or be it the molecule of a crystalline solid, and that point of intersection is called the lattice point. It was the French mathematician Bravais who proved that lattice points can be arranged in maximum of 14 types. In this video, we are going to learn basic 7 types of crystalline solids based on which, or crystalline lattices based on which further Bravais lattices are classified. So coming to first simple lattice structure, that is simple cubic lattice. As the name suggests, it is a cube. So basically, as you all know, in the cube all sides are equal and all the angles are of 90 degrees. So if I tilt it a little bit, you can see it clearly. This is as if we are looking it from the top. So all sides are equal, angles are all of 90 degrees. And this is where as if we are looking it from the front. All sides are equal and all angles are of 90 degrees. So this is the structure of a simple cubic lattice. Coming to next one, tetragonal lattice. What difference can you observe from that of simple cubic lattice? So clearly one side here is different from that of simple cubic lattice. So one of the sides is different, right? And if I tilt it a little bit to have a look from the top, these all sides are equal. So while classifying the crystal lattice structure, one side is called A, other one is called B, and the third one is called C. So if say we call it A, this can be the length of that particular lattice structure. B will be the breadth, and third side, say C, will be the height of that particular lattice structure. So I will not call ABC here, I will call it length, breadth and height here to explain to you. But all you have to know that one side here, for example, when I say height is different, it means that one side is different, right? Because there are two sides, two edges from the front view of the height and two edges from the front view of the breadth. So whenever I am saying height is different, that means that one side of the three, that is height, breadth and length, is different. So in tetragonal lattice, the height is different, whereas from the top we can see that length and breadth are equal, similar to simple cubic lattice. So difference between simple cubic and tetragonal is one of the sides is different, right? Coming to the next one, that is orthorhombic lattice. Now this looks similar to tetragonal from the front view, right? However, again if I tilt it a little bit to have a look from the top, this side is also different as compared to tetragonal. So basically in orthorhombic lattice, again this is view from the front, all the three sides are unequal, the lengths are unequal, right? However, you can still see that the angles, all angles are 90 degrees. So up to here, simple cubic, tetragonal and orthorhombic, all the angles are of 90 degrees. However, the classification is based on the length of the sides. Okay, So this is about orthorhombic. Now coming to the next one, that is monoclinic. If you compare both these, orthorhombic and monoclinic, they look similar in the front view. However, again if I tilt it a little bit, what difference you can observe? This is a view from the top. So this is different as compared to this. So monoclinic is different as compared to orthorhombic. And what is the difference? Here it looks slightly tilted from that view. So basically all the sides are unequal in monoclinic, similar to that of orthorhombic. In both these cases all the sides are unequal. Okay, so the length is not equal to breadth, which is not equal to height. This is monoclinic. And what about the angles? So two of the angles in monoclinic are equal, whereas the third one is not equal to 90. So this is clearly 90. This angle, say beta, is also 90. So this angle, say alpha, is 90, slightly tilted. This angle, say beta, is also 90. However, again if I tilt it, and you can see, so if this is a view from the top and this is the view from the bottom, so this angle is clearly not 90, it is slightly tilted. So this is monoclinic lattice, that is all the sides are different, two angles are same, that is of 90 degrees, and the third angle is not equal to 90. Coming to next one, that is triclinic lattice. And what is the difference here from this particular structure? So here again length is not equal to breadth, which is again not equal to height. So in a way, from the length perspective, it is similar to monoclinic or orthorhombic. However, what is the difference between monoclinic and triclinic? Here none of the angles is 90 degrees. Here two angles were of 90 degrees and one angle was different. So mono means one. So one angle was different here. However, here none of the angles is 90 degrees. So if you see, this particular angle is not 90, this particular angle is also not 90, and from the top if we see, this particular angle is also not 90. So this is triclinic. Coming to next, rhombohedral lattice. Rhombohedral lattice is like simple cubic lattice, however tilted in space. So basically, like simple cubic lattice, all the sides are equal, however being tilted, the angles are not of 90 degrees, however they are equal. So if I tilt it again a little bit to have a view from the top, none of the angle is 90 degrees, however they are equal, right? This is rhombohedral, that is the length, breadth and height are equal and all the angles are equal, but none of the angle is 90 degrees. And coming to the last one, that is hexagonal lattice. Now here I won't say length and breadth here, but say this is a view from the top. So if I call this side as A and this side as B, then A is equal to B here. However, if I call it C, so C is definitely not equal to A and B. And again, two of the angles here are equal, say alpha and say beta, so this angle and this angle, this is of 90 degree. However, if I look from the top and if I call this particular angle as gamma, this is of 120 degree. So in hexagonal lattice structure, A is equal to B, which is not equal to C. So one of the sides is different and two angles are similar 90 degrees and third angle is of 120 degrees. This is hexagonal lattice structure. So this is basically about geometry of crystalline lattice structure, the basic geometry. Based on this, the Bravais structure or Bravais lattices can be subclassified further. Thank you.